Hello guys, welcome to Hardcoder. In this video, we are going to see the Leetcode problem number 433, minimum genetic mutation. Let's get into the question. Leetcode 433, minimum genetic mutation. The problem statement is, a gene can be represented by a 8-character long string with choices from A, C, G and T. Suppose we need to investigate a mutation from a gene string start to a gene string end, where one mutation is defined as one single character changed in the gene string. For example, the mutation here is a valid mutation in which the first string is AACCGGTT, and after mutating, we are for mutation they have mentioned that one character should be changed. So the last character alone is changed, so it makes a valid mutation. There is also a gene bank that records all valid gene mutations. A gene must be in the bank to make a valid gene. So the mutated gene should be in the gene bank to make it as a valid gene. So given two gene strings start and end, and gene bank there, which is a string array. Yeah, this string array. So we need to return the minimum number of mutations needed to mutate from start to end. If there are no such mutations, return -1. So this is all about the problem statement. So note that valid starting point is assumed to be note the starting point is assumed to be valid. So it might be it may not be included in the bank. So let's define the problem first. Let's get into the paint. So we'll define the problem. So they'll be giving us strings start. So first of all, yeah, gene represented using 8-length character. So what is a gene? Gene is nothing but 8 length 8 length string. This is the first point for gene, and next point is the character present in the gene will be A, C, G and T. So A, C, G and T. Okay, so suppose we need to investigate the mutation. We need to investigate the mutation from start to end, where one mutation is defined as single character change in the gene string. So after we know about gene, we'll see what is mutation. Mutation is nothing but changing one character position, one character from the current gene. So if we change a single character from the gene to any other character, which are the valid gene characters, we can say it as mutation. So this is the condition for mutation, and there's also a gene bank. So it stores valid genes. So bank will contain valid genes. So what is a valid mutation? So we have discussed what is mutation and what is valid mutation. Valid mutation is nothing but the mutated string. So when we change a single character, so it's nothing but, let's see, so a gene after mutate we get a mutated string, right? Mutated string. So this mutated string should be present in the given words array, which is bank. So if the mutated string is present in the bank, we call it as valid mutation. So this is the point to be noted here. And they are giving two strings start and end and gene bank. We have to return minimum number of mutations needed to move from start to end. If there are new mutation, we return -1. So they'll give start as a gene start and end. So we need to mutate the start gene till we reach the end. So it may be directly moving to end, or it may be forming a series of mutation. So mutation 1, mutation 2, mutation 3, and finally end. If we are unable to reach the end, for example, if we are starting from the start, moving to a mutation, so let's call it as M1 and M2, and that's all. So we are when we are ending here, in that case we'll just return -1, or else if we are able to reach the end, we'll return the number of mutation. Consider this case. So in this case, the mutation number of mutation 1, 2, and 3. So number of arrows we have used. So the answer will be 3. So this is the input for this problem is going to be the start and end, and also words array, which is bank. Bank is a word array, string array. So output should be minimum number of mutation. Valid mutations. So we have mentioned it, right? So yeah, valid mutation. So if not able to reach the end from start, will return -1. So this is what they have asked, and so we need to think about the corner cases. So they also have given the condition that starting point may or may not be present in the bank. So it's also a point to be noted, and they have stated that you have to check for the corner case. That is, what happens if start is equal to end. So in this case, actually this corner case is not present in the given problem, but when you think about this corner case, so if start is present in the end, so what will be written? So the answer for this question is going to be, I think they have not given this kind of edge case. So when you get into the interview, you must ask also these questions. So that's it. And yeah, how are we going to approach this problem? So we have defined the problem successfully, and now let's move on to approach the solution for this problem. So approach. So how are we going to approach this problem? So first we have a start word, right? So from start gene, so let's start gene. So from start gene, uh, we can try every possibility. So it will be 8 length string. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 length string, right? So firstly we'll change this first index to show the valid words, which is A, C, G, and T. So A, C, G, and T. So we'll change the first character, first position of the start, and second position, third position, and every we'll try for every possible next mutation. And firstly, we'll mutate and check. After changing mutation, we'll check if the given word, formed word, is present in the word or not. So let's have it as a word bank. So after mutation, if the word is present in the word bank, we'll again continue with that given word. So formed word. So consider the test case. This. So let's have a slightly bigger example. So in this case, so let's see. So firstly, for the word a, so we'll consider using this case. So a short word is a c c g g t t, right? So firstly we'll replace a by what are the valid words? So a c g and t, right? So the current word will be changed to c. So we'll check whether the mutated, this is a mutation, valid mutation. So it is a mutation, we'll check whether it is a valid mutation. So if we check the bank, we are not able to find the word. So again we'll check for other mutation. So we'll go for other mutation, which is we'll replace it by G. So this given word is not present. So again we'll go for T. So again this word is not present. So we'll continue. We'll leave this A as it is. So it was a G C and T, right? So we'll mutate this word. So we'll make it G, C and T. So any of the word is not present. So again we'll move to next word, which is C. So we'll replace the C by A, and when we mutate, we can clearly see that we'll check with the every bank words, right? So unique C, A, C, G, G, T, A. So it's not a match. So I'll continue to change the next character, which is C. After that we'll replace C by A. So we'll check AACA whether it is present. So it's not present. So we'll go with AACG. So AACG is not present. So again we'll replace with AACT. So this word is not possible. I mean it is not present. So we'll move on to next question. So we'll replace the G by A. So we'll check whether AACCA is present or not. So now it's not present. So we'll replace it by C. So AACCC is not present. So we move with T. So when we mute it to C, it's not present. So again, we'll move to next character, which is 1, 2, 3, 4, 5, 6, sixth character. So we'll replace the G by A. We'll check whether this is present or not. So AACCG is not present. So we'll move to check with other character. So when you mutate AACCGC, AACCGC is not T, is not present. So when we keep on moving, I guess when we change the last character to A, we can see that the word is present in the bank, which is AACCG, yeah, TA. So the given word is present. So we'll add it to the we'll continue with the this word. So we'll mute it to the current this word and we'll check for possible pair. So it will be going on. So we can consider this problem as a graph problem. So we need to check for other every possible ways, right? So from a word we need to find, so if it is a gene, we need to go to every possible ways words. So it can be anywhere. Then for each word there is I mean many possibilities. So For each word there are many possibilities, so you need to go to every possible words. So this words too may have many mutation. So yeah, it may be cycling back to the word. So let's consider this as a graph problem. So we can have two possible ways, which is DFS and BFS. So which to choose from those? So we can choose BFS. Why are we choosing BFS? Because when we have the minimum value in the depth D, so when this is the answer, when we use DFS, we'll do unwanted checks. That is, we'll keep on go to beyond the depth D and check for the answer. So when we consider this BFS, this unwanted calls can be eliminated. So we'll go with BFS. So how are we going to do it BFS? So firstly, we are going to create a queue with start word. So firstly we'll have a start word, and firstly we'll and also we'll have a level. So firstly initially level will be 0. So we'll go into the queue and take the word, poll each word. So we'll firstly poll this start, and we'll find the valid mutations of the start. So we'll add them up into our queue, and yeah, we'll add all the possible ways, and we'll continue. When we are continuing to next level, we'll increment the level to 1, I mean level by 1. So in this again we'll repeat the process, and uh, add the valid mutations. So we'll add them, and finally when we reach end, when polling up, we'll return level. This is the approach we are going to use. And finally, if the queue is empty, we'll return -1. So this is the algorithm which we are going to use here. So if you are getting somewhat idea about this approach, will be very clear in the coding section. So let's get into the coding section. Yeah. Initially, we'll create a queue. So queue of string queue will be a new linked list, and we have a set string which will be storing registered strings, and we'll have a level value of 0. So for initially we'll add the start word and into the queue and also the set. So while queue is not empty, so initially we'll get the size of the queue and id to every element in the current level. So we just run the while loop till the size, and first we will pull the element, and we'll create a character array out of the old string. So we'll go with every possible mutations, right? So before that we'll check whether the old string is equal to the end string or not. So we'll return the level, or else we'll write it over each array, each scatter, and firstly we'll have a previous value. So current character will be true. So we'll store the current character into true, and we'll iterate over each character. So it will be uh, each mutated character will be A, C, G, and T, right? So we'll get a character array, mutated character, which will be new character array of A, C, G, and T. So for each character in mutate array, so let's call it as M, mutate char, we call it characters. So if previous value is equal to current value, we'll continue. So it will not be a valid scenario for mutation, right? So there will be no change. So we will be continuing. If not, we'll update and change the current character to M, and we'll create a string out of it. So we'll call it as mutated string. Mutated string will be string dot value of error. So we'll change the current array into a string, and we'll check the current word in the bank. So how can we do that? We can just have a helper function. So before that, we'll check whether the visited the mutated string is already visited or not. So visited or sometimes mutated string already visited. We just leave it. Or else if it's present in bank, the current word. So mutated string and word. So if the mutated string is present in the bank, which this helper function is present, will return the muted whether the current string, that is mutated string, is present in the bank or not. If so, we'll add it to visited array, which will be mutated string, and also we'll add it to queue mutated string. This is what we are doing. So this loop will iterate for each character, that is A, C, G, and T, and finally we'll replace the current index to previous character. The have iterated over all positions of the current string, which is P, and finally we'll increment the level. So and when the queue is empty, we'll return -1. So this is one, and we need to write the helper function, which is present. So this will be returning a boolean value. I'll get the string and also a string array bank, and we iterate over each string in the bank, which are valid mutation bank. If s dot equals yes, valid mutation will return true, else will return false. So we are not using a set here because there is overhead in hashing. So instead of using the helper function, we can also use a set uh, by using a set. So we'll add the banks, that is the valid strings, into a set, and we'll check them in big O of 1. But in this case, they have mentioned that the size of the bank will be maximum 10. So instead of using the set, we can just iterate over each character, each string, and find whether it is the current string is present in the bank or not. So and if it is present, it will be returning true, or else it will return false. So let's check with the test case. Set of visitor is no hash. P dot to character. And it's working fine for sample test case. So let's check with other sample test cases. That's working fine. Let's submit it up. It's accepted. And the time complexity by some process drop. So what will be the time complexity? It's nothing but the number of characters in the number of words in the bank, which will be bank.length. In this case, Yeah, bank.length will be the time constant. Space complexity is order of bank.length. Yeah, because maximum will be storing the maximum number of strings in the bank in the visited array and also the in the queue. So approach for this question is BFS. Yeah, approach for using BFS, and that's all about this video. Thanks for watching this. Have a great time.